Hello, my name is John Gardner. I'm a design engineer for power products at Linear Technology. Today I'm going to discuss the LT3971, an ultra-low quiescent current step-down regulator. When a buck converter is regulating an output voltage, some input current is required to power the control circuitry and various features of the regulator, even when the part is providing no power to the output. We call this current the quiescent current. When the regulator is delivering a large amount of power, the quiescent current is not a noticeable portion of the input current. But at lower output loads, the quiescent current can become a large portion of the input current, so it can significantly degrade efficiency. The LT3971 leads the industry by consuming only 2.8 microamps of quiescent current. This is more than an order of magnitude less current than previous low quiescent current regulators. The curve shows the current measured when the part is regulating a 3.3 volt output with no load. It is important to realize that this is not the shutdown mode current or sleep mode current. This is the average input current while the output is being regulated. The input current remains only a few microamps across the full input voltage range from 4.3 volts all the way up to 38 volts. If you need low performance, you might reach for an LDO regulator. However, both an LDO with 3 microamps quiescent current and an ideal LDO are less efficient than the 3971 at loads as low as 20 microamps. Since the LT3971 is a switching regulator, it also gets efficiencies as high as 88% up to its maximum output current of 1.2 amps. The LT3971 achieves the best of both worlds with good efficiency across a wide load range. The best way to showcase low current performance is to drive the part from a battery or capacitor to see how fast the input supply depletes. Here we added an 1000 microfarad input capacitor to a standard demo board. We selected a cap with only half a microamp of measured leakage, which is important because many electrolytics can have leakage currents larger than the LT3971's quiescent current. When the input cap was pre-charged to 16 volts and left to power the regulator, the output stayed in regulation for over an hour. This demonstrates how the LT3971 can be used in automotive or other battery-powered systems, where maximizing battery life is critical. Many of these systems have tight power budgets, and the use of the LT3971 allows more margin when speccing capacitor leakage or the current consumption of other circuitry, resulting in a more robust solution which is easier to design. The LT3971 quickly and seamlessly transitions between light load and heavy load operation. The output settles in only 40 microseconds after receiving a half-amp load step. This shows how the LT3971 is a good choice for pulsed power applications. Now let's look at some of the switching waveforms at low output loads. To achieve low quiescent current, the LT3971 will deliver a pulse of charge to the output and will then go into a low current sleep state. During the sleep state, only the internal voltage reference and air amplifier monitoring the output stay powered on. When the air amplifier detects that the output has fallen slightly below regulation, the whole circuit wakes up and delivers another pulse of charge to the output. The LT3971 delivers power in single pulses rather than switching multiple times before going to sleep. This prevents excessive charging of the output capacitor. As a result, the LT3971 has very low output ripple, less than 20 millivolts peak to peak across the full output load range. The LT3971 typical application circuit looks like many of Linear's other wide VIN range step-down regulators. No features have been sacrificed for the low current operation. There is an enable pin to turn the part on and off, a PG pin that will indicate when the output has come within 10% of the regulation value, an external soft start pin to limit inrush current on startup. A fixed switching frequency is programmed using a single resistor, and the part can be synchronized to an external clock. In conclusion, the LT3971 is a full-featured step-down regulator with only 2.8 microamps of input current when regulating a low ripple output voltage. It accepts inputs between 4.3 volts and 38 volts and can supply up to 1.2 amps of continuous output current. High efficiency at both low and high loads makes this product ideal for automotive electronics as well as general battery-powered or pulsed-powered applications. Linear has a growing family of ultra-low quiescent current step-down regulators with a range of deliverable output powers and input voltage ranges of up to 60 volts. For more information, please visit us at www.linear.com. Thank you for watching.